Hey everybody, this is Dr. Adam Rindy. I'm speaking with you today about metabolic flexibility. This is a great slide from an article on metabolic flexibility that was appeared in Endocrine Reviews, August 2018, volume 39. The author is Ruben Smith. I really like it because it encapsulates what happens with the intake of glucose. Metabolic flexibility is a term that's very important to understand. It tells us how well someone is going to utilize substrates for fuel, meaning how well someone will be able to burn glucose for fuel as well as fats for fuel. The ability to switch back and forth between these substrates is determined as the ability to be metabolically flexible. This is sort of an ideal state for someone to maintain leanness and also to prevent insulin resistance and prevent the progression to type 2 diabetes. So let's dive in and see what happens to the body when we take in glucose. Now, I want to preface this to say that carbohydrate is extremely important as a substrate for fuel. The debate back and forth as to the benefits of a low carb diet versus a high fat low carb diet is ongoing, and my opinion is really at the point of just to understand what's going on in the body to create the best metabolic balance. Glucose, when it enters into the body, triggers something called insulin, which is secreted from the beta cells in the pancreas. When glucose is in abundance, we have an elevation of something called the insulin-glucagon ratio. Insulin is an anabolic hormone that's present in times of plenty, meaning when we're well fed and we have the ability to store. Glucagon is a catabolic hormone also secreted by the alpha cells in the pancreas, which is a catabolic hormone which is used to extract nutrients from our storage base. So when we have glucose entering the body, we see an elevation of the insulin-glucagon ratio. So this is a body-wide event affecting several organs. I think the first place to start in this discussion is to see what takes place at the liver. So when glucose enters the body and the insulin-glucagon ratio is elevated, the liver will uptake glucose and start forming fats. It's called lipogenesis. And we also will see a decrease in glycolysis, which is sort of a liver. In the liver, this means that the breakdown of glucose as a fuel source goes down. So typically glycolysis is the breakdown of glucose by certain enzymes that release energy and something called pyruvic acid. We'll see that go down in the liver. We also see gluconeogenesis decrease because the liver will not need to make glucose as a fuel source, which is one of the main roles of the liver when glucose is not available. And we see the decreased breakdown of glycogen and decreased formation of ketones. So let's jump over to the fat region. And so in the adipose tissue, we see an increase in synthesis of fat storage molecules and a decrease in breakdown in fats. So the fat deposits will increase due to the fact that there's an abundance of nutrients. So this is one of the mechanisms of the development of obesity, is that the excess insulin to glucagon ratio will lead to excess storage of fat. Now, one of my favorite subjects is what happens in the muscles. So skeletal muscle is a major deposit region for glucose. So if we have good amounts of skeletal muscle, then we give the ability for the body to dispose of glucose into tissue. And that tissue, especially in exercisers, can really be a important vehicle for preventing problems with insulin resistance. So what happens in skeletal muscle in the presence of glucose is we see increased glucose uptake and increased burning of glucose. So this happens because insulin receptors come to the surface, insulin binds, which triggers something called GLUT4, which is a receptor on the plasma membrane, which pulls glucose out of the blood and puts it into cells. So in this case, also the fatty acid oxidation goes down. So, in a fasted state, the other extreme, someone who's exercising at a very kind of low intensity rate for, say, 30 minutes to 90 minutes, we'd see increased fatty acid oxidation. The body would be using fatty acids for fuel. Another important point that I want to bring up is the brain. So when we have a high insulin to glucagon ratio in non-insulin resistant folks, we'll see a decrease in appetite. Insulin will suppress appetite in the central nervous system because we are in a state of being fed. That's a perfect mechanism. However, when it becomes imperfect in insulin resistance, we see that the brain is not perceiving the well-fed state. So we get insulin resistance and also likely something called leptin resistance. And then we see that the brain senses that the body is not well-fed, so there is no appetite suppression. And so even in a well-fed state, we'll become hungry. So this is sort of a really good overview of understanding what happens with glucose. It is one of the key takeaways is to learn how to balance carbohydrate into your life with other substrates of fuel, protein, fat, and also the importance of resistance training to help this system function. When we get too far to the extreme, the system falls apart. And that's also the case with, probably when we're doing a lower carbohydrate diet for too long. So metabolic flexibility is something we strive for, which is having a lifestyle which will lead to balance and that the system will function well. Hope this was helpful. My name is Dr. Adam Rindy, Sound Integrative Health, Bellevue, Washington. If you have any questions, please leave some comments below. Thank you.